Hello class, today we're going to go over 4.2 notes in Algebra 2, which is factoring quadratics. We'll start with the basics, factoring out a greatest common factor. For this, you're going to look at the numbers in front of each term. First, to determine what they're all divisible by. And for this specific problem, they're all divisible by 6. Then I look at the x's, and I can take one x out of all of them. I can't take out more because this last term only has one x. If I do that, I have a 2 because 6 times 2 is 12, x cubed, since there's 3 x's left because we took one out, minus 1, 6 times 1 is 6, x, plus 4, 6x times 4 is 24x, and that's it. For number 2 here, it's a little different. They both have a pi, so we can take that out. Looking at the r's, the most we can take out is 1r, and then we can take out 1h. So when we do that, if we take a pi, an r, and an h out of this first term, the only thing that's left is 1r, plus, for the second term, the only thing that's left, if we take out pi r h, is the 2. And we're done. Next, we're looking at difference of two perfect squares. When we do this, we're going to be factoring into two sets of parentheses. X squared is x times x, so I'll put an x in the first spot of each set of parentheses. 25 is 5 times 5, so I'll put a 5 in the last set of each set of parentheses. Now notice there's no middle term in this quadratic, which means that we need that middle term to be able to cancel out. So recall from Algebra 1, we multiply these two middle terms together, these two outside terms together, and that's how we determine how we would get a middle term. So if we want this to be a 0, these need to be opposite signs. We'll follow the same process for number 4. 49 is 7 times 7. A squared is a times a. So I have a 7a in the first spot of each set of parentheses. For the 81, it's 9 times 9, and since there's no middle term, again, these need to be opposite signs. Next, we're looking at trinomial squares. So for number 5, let's begin by go ahead and factoring it into two sets of parentheses. X squared is x times x. Since there's no coefficient to x squared, all I have to worry about is what times what equals 16 that will add up to 8. Well, 16 is 4 times 4, and 4 plus 4 will equal 8 in the middle. Notice we have x plus 4 times x plus 4. Since those are both the same, we can write this as x plus 4 squared. Follow the same process for number 6, two sets of parentheses. R squared is r times r. What times what equals 4? That one combined will give you a negative 4. Well, if we have a 2 and a 2, and we make those both negative, negative 2 times negative 2 gives us the positive 4 at the end. And then negative 2r here, plus another negative 2r will give us that negative 4r in the middle. Now, these are the same exact expression in both sets of parentheses, so I can write this as r minus 2 squared. For number 7, the first thing I want to do is take a 3 out of all of these terms, because I notice they're all divisible by 3. This will make it a little easier. If I do that, I get x squared plus 6x plus 9. Now, I just have to worry about factoring x squared plus 6x plus 9. I'll still bring that 3 down in front of my two sets of parentheses. So now looking at this new expression, x squared is x times x. 9, if we do 3 times 3 and make them both plus, it will also give us the 6 in the middle. Again, we have two sets of parentheses they're same. We can write this as 3 times that x plus 3 squared. For number 8, all three terms are not divisible by any number other than 1, so I'm just going to jump straight to two sets of parentheses. For 25, I'm going to use 5 times 5. X squared, x times x. 1, the only option we have is 1 and 1. Now we have to make sure this will work out to give us a 10 in the middle. So if I multiply these insides together, I get 5x. Outsides together, I get 5x. If I want it to equal a 10x in the middle, they both need to be positive. Notice both of these are the same, so I can write it as 5x plus 1 squared. Okay, so for this next section, we're going to have to do some guess and check. So first I'm going to create my two sets of parentheses. X squared is x times x. Now I have to think to myself, what times what equals 12? That will add up to 7. Well, my options for 12 are 6 and 2, 3 and 4, 1 and 12. I would use 3 and 4. And they both need to be positive to have a positive 7 in the middle. For number 10, I'm going to follow the same process, 2 sets of parentheses. M squared is M times M. For 40, my options are 4 and 10, 8 and 5, 40 and 1, 20 and 2. Looking at these options, I believe we could get 13 if we use 8 and 5. Now for it to be a negative 13, these both need to be negative. That will also give us the positive 40 because negative 8 times negative 5 is a positive. For number 11, same process, n squared is n times n. For 24, we can use 2 and 12, 3 and 8, 6 and 4, 1 and 24. So if these are our options for 24, to get a 5, we could use the 3 and the 8. Now notice it has to be a positive 5, so the 8 needs to be positive, the 3 can be negative. We also want to make sure that when we multiply these together, we get the correct sign in front of the last term, and we do. For number 12, 2 sets of parentheses again. X squared is x times x. For 32, we have 2 and 16, 32 and 1, 8 times 4. And looking at these so far, I can already tell 8 and 4 would work. It needs to be a negative 8 to get a negative 4 in the middle and a positive 4.
Okay, so next in notes, we're going to go ahead and look at factoring quadratics that have a coefficient in front of the x squared. So for these, there's going to be some more guessing and checking. For this first problem, 2x squared plus 5x plus 3. We start with 2 sets of parentheses, as always. 2x squared, luckily 2 is prime, so I use a 2x and a 1x. Now we just have to decide for the 3. Is it 3 times 1? Where we put those? Right? Are we going to put the 3 here, or are we going to put the 1 here? So let's check. If I put the 3 here and the 1 here, that gives me a 3x and a 2x. Okay. If they are both positive, that will give me the 5x I need in the middle. It will also give me the positive 3 I need at the end. So my final answer is 2x plus 3 times x plus 1. For number 14, we start with 2 sets of parentheses again. 7 is prime, so I use 7k and 1k. Now for the 6, we have to decide what to use. There's 6 and 1 or 3 and 2. And we also have to think about the signs when we do this. So I want to get a 19 in the middle. To get a 19 in the middle, let's try the 3 and the 2. So first I'm going to show you if I put a 3 here and a 2 here, I get a 3k and a 14k when I check for the middle. 3 plus 14 is not going to give me a 19. Okay, so I know that that didn't work. Now that doesn't mean that 3 and 2 are not an option. It just means they don't go there. So let's try swapping them. If we put the 2 here and the 3 here, I get a 2k and a 21k. I can get a positive 19 if the 21 is positive and the 2 is negative. So that tells me this needs to be a minus and this needs to be a plus. I'm going to make sure that all my signs will work out. So we already know it'll work out for the middle, but for that end term, negative 2 times positive 3 is in fact a negative 6. So we're good. Our final answer is 7k minus 2 times k plus 3. Now for number 15, notice that first term is negative. We don't like having a negative first term, so I'm going to take out a negative 1. And this will become 21b squared minus 4b minus 12. So now we'll factor the 21b squared minus 4b minus 12. I do bring down the negative 1 in front. We want to bring that down all the way down to the final answer. Both 21 and 12 have multiple factors, so we have to determine what to use for each. Our options for 21 are 7 and 3 or 21 and 1. Our options for 12 are 12 and 1, 6 and 2, or 3 and 4. Well, for the first one, for 21, I don't think we'd use a 21 and a 1 just because we have a smaller number in the middle. So I'm going to guess that we're using a 7 and a 3. Now I have to determine what I'm going to use for this minus 12 here. I don't think it's going to be a 12 and a 1. Like I said, again, because it's bigger numbers and you have a smaller value in the middle. It could potentially be 6 and 2 or 3 and 4. At this point, you kind of have to guess and check. You could do that in your head, or you can write it down to guess and check. I am going to put let's do 6 and 2. So I'm going to put a 6 here and a 2 here. That would give me an 18b and a 14b. Now we need this -4 in the middle. So we could get that if it was a -18 and a +14, which means this would need to be a -6 and a +2. We just want to make sure is -6 times +2 and -12 at the end, and it is. So our final answer is going to have that negative sign in front. It can either be a negative or -1, up to you, times 7b minus 6 times 3b plus 2. And that's it for that problem. Next, we're going to look at factor by grouping. For 16 and 17, they've already done half the work for you. When you factor by grouping, you split the problem down the middle, and you say to yourself, what do the left and the right have in common? So notice in this first problem, they both have an x plus 5 in common. We are essentially factoring out that x plus 5. So I put x plus 5 first. Then I start a new set of parentheses, and I say to myself, if I factored out the x plus 5, what do I have on the left that's left over? And that's then a. On the right-hand side, we have the minus b left over. So we put that in its own set of parentheses, and we're done. For 17, same process, split it down the middle. Both left and right side have an h minus 3 in common. What's left over is the x squared and the plus 3, which goes in its own set of parentheses. Now for 18 and 19, they did not do any of the work for us. So what we're going to do is we're first going to split it down the middle like we have been. But then from there, on the left-hand side, I say to myself, what do they have in common? Well, 6 and 3 are both divisible by 3, so I'm going to take out a 3. That gives me 2x minus y. Same process on the right-hand side. I look to see what they have in common. They both have a z, so I'm going to factor out a z. And then I have 2x minus y left over. So notice, both sides have the same thing in parentheses. That's good. You want that because you're going to factor out that parentheses that they have in common, 2x minus y. And then the second set of parentheses, you put what's left over. So the 3 and the positive z. And you're done. We're going to follow the same process for number 19. Split it down the middle. I'm going to take an x squared out of x cubed and 2x squared. Okay, so we can take out 2 x's. That's the most we can take out. We have x minus 2 left. On the right-hand side, I can take out a 3 to get x minus 2. Now looking at these, the parentheses both have the same thing. That's a good sign. It means I'm on the right track. So I'm going to take out that x minus 2. And then in another set of parentheses, I'm going to put what's left over, which is the x squared plus 3. And we're done with that problem, as well as the notes for today. If you have any questions, be sure to contact your teacher.